As an example of broad pathogen identification, I chose here to use swine. And in this case, I will be focusing on deep respiratory problems in pigs, pigs that are showing coughing or dyspnea. So we took samples. Actually, we didn't take the samples, but veterinarians from Belgium and the Netherlands took samples between actually the winter period, where you see most of these respiratory problems. And we included here 50 case farms from cases that were brought by a selection of vets, because this is important. If you want to do proper epidemiological studies and genomic epidemiological studies, you should include material that has been collected properly. And you see already that a lot of vets are putting a lot of effort in taking really good materials. Now, how have these samples been taken? So these vets have been taking tracheobronchial samples. So they put in a catheter in the trachea of the swine, and then they collect the mucus, and then they purify with the PathoSense swab. And we have tested these samples broadly with PathoSense. So if we look to these results, so this is actually more a classic type of reporting, where we would give an overview of all the pathogens that can be found during the past winter season. And if you look on top to the viruses, what we would normally do with these kind of respiratory problems is we would screen for swine influenza A or PRRS. And then you would see that we, of course, pick up in a lot of cases these both viruses, but there is much more going on. And I think this is really interesting because we also pick up a lot of neglected and novel viruses, of which some of them can really have a potential pathogenic influence. We see here cytomegalovirus, coronaviruses, PRCV, porcine hemagglutinating encephalomyelitis virus. Then also the pneumoviruses, which are related to the human respiratory syncytial virus and bovine respiratory syncytial virus. So we know that these are not pathogens or viruses that are not causing any disease. We also picked up para-influenza virus. So you see there are many cases where you pick up very interesting things, and that with only looking to the known things, you will not come up with a conclusion. Also for the bacteria, you pick up a lot of relevant bacteria already with the system. But of course, what is the meaning of finding a Mycoplasma hyoaurinis or a Glasserella parasuvis? Because they are often also present as carriers in the animal. So there we should go into more depth as well for a better understanding. And of course, this will also be important from a One Health perspective. The pickup of coronaviruses or an influenza D virus that we picked up in pigs, but that can also cross to cattle is, of course, an interesting finding. Now, how should this evolve in the future is that actually it should be possible to give a real-time overview of the pathogens that are circulating in veterinary medicine. And I think we need to distinguish the pathogens with an epidemic behavior, endemic behavior, and then also maybe the ones that are circulating there, but maybe have a potential zoonotic concern. And first, I will focus on the pathogens with a typical epidemic behavior. And I think I will give you an overview. So these are mostly the pathogens that are occurring in a seasonal manner. So they come and they go. One example, I think, is influenza A, where you have the typical winter season, and also equine herpes virus, one that I will use here in the presentation as an example. So I will start here with the epidemics. And where is the pathogen genomics becoming interesting is that it will allow you to make decisions on the farm in terms of vaccination or treatment, and also to trace the sources of infection. So as an example of influenza, so the samples that we monitored in the pigs, the influenza positive samples, we were also able to determine the hemagglutinin and the neuraminidase subtypes. So as you know, influenza has a segmented genome, so there are 8 gene segments, and this virus undergoes a lot of drift. So the hemagglutinin and the neuraminidase are causing are inducing the neutralizing antibodies, and so there is a continuous pressure of the immune system. And if you have different influenza virus strains infecting the cell or the host at the same time, you can have an exchange of the gene segments. So this is quite important to monitor it very closely. Now in swine, we have very common hemagglutinin and neuraminidase types, which are the H1N1, H1 and 2, and very seldomly also the H3 and 2, which also has, of course, the public health risk. And what is also apparent is that we have the classical H1 strains, but also the H1 strains which have the pandemic H1 type. So this is really interesting to have not only the presence, the detection of influenza, but also the strain information immediately from the diagnostics. And this is an overview of the typings that we did during the past winter season. And then you see that almost 40% of the strains are having the pandemic H1 subtype, and while the other part has mainly the classical swine H1 part. So why is this interesting? Because if you know that you have a pandemic H1 type, you can guide your vaccination because you have two different vaccines, one containing the classical H1 and the trivalent component, and one is specifically containing the pandemic component. So if you have this pandemic strain, you could really target your vaccination towards this pandemic component. In the future, it should be very interesting also to look to the other gene segments. So we didn't do that for now, but that is certainly the plan to see how the gene segments are being exchanged in real time in the population.